Alrighty, guys, welcome back to Isaac's Dev Corner. Today we're going to be starting the C Sharp series. I'm really looking forward to this series. I've just finished my C Sharp object oriented programming course at university. So I'm here to teach it now. I feel like I have the basics understanding of how it all works, but there's definitely so much more to grasp in object oriented programming, and obviously a lot more which I'm going to be learning in the future. But for now, I'm going to be telling you guys the basics about it. This is going to be a series and a playlist called C Sharp Object Oriented Programming. Um, Regarding my other playlists, I have a networking playlist about computer network IP addresses routing, which is a in another playlist called networking playlist, I think, computer networking. So I'm going to be publishing all the information I'm learning online, sort of as a portfolio of my knowledge and understanding of everything so far. All right, so let's get started. So yeah, C Sharp, and I just want to let you guys know I'm taking resources from W3 Schools, which is an online platform for learning, coding, and etc. So a lot of the screenshots and things like that will be cited from W3 Schools. So if you want to check them out, you can check that out. It's a really good site for learning how to code. They got all the different languages: PHP, Bootstrap, HTML, all that different kind of stuff. It doesn't go into deep depth, but nonetheless, it goes into the beginning levels, which is really all you need to get the basic grasp on how to understand things. And it's organized in a chronological manner, and it's free. Anyway, guys, let's get started. Alrighty. So about C Sharp. C Sharp at a glance. So it's a general purpose object oriented programming language created by Microsoft in the 2000s. So approximately, yeah, 2000. Start of the century. Um, Part of the .NET framework, so a powerful platform for building various applications. It's a versatile language used for web applications, desktop software, mobile apps, games, cloud servers, and more. It's known for its readability, efficient performance, and rich features. So I've got a little infographic down the left-hand side here. So it's got a difficulty star of 3 out of 5, popularity 4 out of 5, and the date it was created. So yeah, Windows applications, business enterprise applications, and software. So pros of C Sharp, it's in the .NET library. It has access to all the repository and functionality and support. It's transferable, so the structure you learn is transferable to other languages like Java, Object-C, PHP, and C++. Um, C Sharp, along with Java, is one of the top languages in demand for employers. Right now with the turbulent job market, it's hard to say what exactly is going on, but nonetheless, I think it's good to acquire the skills of object-oriented programming. But this video is not about jobs in IT. This is about C Sharp and object-oriented programming. This part of the series. So yeah, another cons of it. It's not necessarily for newbies. Potentially Python is a good start, and cross-platform. It's based on C language, so loses any cross-platform capabilities because of the integration with the .NET. Yeah, so some common applications that were built with it is Stack Overflow, Evernote, and it was created by Anders Heisenberg right there. Okay, next bit key features. Its object oriented paradigm encapsulates data and behavior within classes and objects. We're going to be exploring classes and objects. When I first started, I was very confused about what a class and an object is, but we're going to be going into that in depth. Okay, so promoting code usability, reusability, and maintainability. So strong typing enforces data type safety, reducing errors and improving code readability. So garbage collection, automatic memory management, freeing developers from manual memory allocation and deallocation. That helps a lot in that kind of area. So it's language integrated query, LINQ, powerful feature for querying and manipulating data from various sources. Uh, Asynchronous programming support enables efficient handling for long-running operations without blocking the main thread. Yeah, the rest you got there is cross-platform capabilities and a good library and integration with Visual Studio, which is the IDE that I'm going to use and which we'll be using in this series. Yeah, and I'll show you how to install that in a second with some slides. But yeah, so you can see here this little chart, rich libraries, scalable and adaptable, component orientated, object orientated, simple, etc. So it lets you build console apps, desktop apps, and all these different kinds of systems and applications that you can build. It's quite awesome. Yeah. So yeah, it's a powerful object-oriented language. For those coming from Java or C++, you should be able to pick it up and the syntax pretty quickly. It is case sensitive, so capital A and A are different, for example. Lines terminate with semicolons, so that's how that works. Code is put into blocks, encased by curly brackets. Inline comments start with // and block comments start with /*. XML is ///. And yeah, so here's a snippet of a switch case statement here, along with some, console write lines and a little while loop here. And yeah, there we go. Next bit. So how are you going to install this, guys? I want you to go to the Microsoft Visual Studio download page. Once you're there, and there's tons of videos on this video is not about how to install it. It's more so about just how to set it up. Once you're there, press the .NET development, select all the options that you want to select, depending on how much storage you have and etc. But obviously do what we've got here and more if you want to do that. Then after that, you'll get this page. We can create. We can go to the install new features, and then you want to be able to get the console app.NET Core is what we'll be using to play around with the code and learn. So we're using a console app. We're not creating a desktop app, just a console app, which is going to be done in the console, which is the little thing that pops up, like kind of like the CMD kind of where you interact like that. Okay. So once you've done that, you want to create a project and give it a name, Hello World or something, put it in a folder, and do that. Right here. Okay. So when you're greeted with the start of when you create a console app, it will look something like this. So you have your using system, your namespace, your class, and your main function, which is what we'll jump into. Okay. So I'll just explain what this means. So line 1 is using system. So using system means that we can use classes from the namespace. So we can use our classes and different types of methods from this system namespace, which is quite powerful. It allows you to use like console write line, all this kind of stuff. Okay. That sounds confusing at start, but basically within this, there's different methods and all these different things you can use, which are used to then do functions. So maybe you want to like print something, maybe you want to read something, that kind of stuff, right? So line 2 is a blank space. C# ignores that, so it makes the code more readable, putting spaces out for the person to, see. So we're still recording. All right. So line 3, which is namespace hello world. So namespace is used to organize your code and its container for classes and other namespaces. So depending on what project you're doing, maybe it's a project called Hello World. Yeah. Then you're going to be operating under the Hello World namespace. So you can access different methods and classes and etc. within that namespace. Okay. So you can have another .cs file with that namespace, and then you can then extrapolate information from that methods, all that kind of stuff, right? Line 4. The curly brackets mark the beginning and end of the code block. So beginning and end. So everything in here is encapsulated. I guess you could say encapsulated or stored within the namespace of Hello World. Now that should make sense. And line 5 is class is a container for data and methods, which bring functionality to your program. Every line of code that runs in C# must be inside a class. For example, we named this class program, which is like the standard version. So line 7, another thing that always appears in C# programs is a main method, which is down here. Any code inside of it will be executed. You don't have to understand how the keywords before and after main, you will get to know them bit by bit reading this tutorial. So don't worry about it. This is basically the entry point for your application. It's where everything starts and it's what will be executed. And then from there, it will then grab information from here and here and here, but that's your entry point into your application, if that makes sense. So yeah, it's a bit confusing at the start, but you'll get it. Line 9 is just a console, is a class of the system namespace, which is what I just referenced up here. It enables you to console.writeLine, which is being able to write a line in the console. So when the console opens and you run the program, you will get the console open and you'll have the write line hello world. and we'll print that, and that will be your output. Okay. So note every C# statement ends with a semicolon. So boom, and you got that one up there. And C# is case sensitive, so my class is different to my class if they have different capitalizations and they have different meanings, right? So that's that. You can give this little example thing a little go. So obviously, just give it a shot. It'll be main, and then console.writeLine. Okay. So your entry point to the application, and then console.writeLine, which is using from the names using from the system, which is gives you the capabilities to do the console.writeLine. So here's some examples. So to output values or print text in C#, you can use the I forgot to put the bit there. But yeah, so console.writeLine, hello world, that should print hello world into your console. Obviously, you'd have to have the whole program, so you'd have to have all this stuff set up. I just printed this on a line just so you can see what it looks like. But basically, console.writeLine would be within this bit right here. Vice versa for the rest of these here too. So you can print multiple things. You can do some addition here with integers. And then you've got, yeah, that's the same thing now. This one's just console.write instead of writeLine. And when you console write, you don't create a new line. Does that make sense? So maybe I'm going to do a console writeLine, hello world. So hello world will be here, and then down here will be the where it will finish. But this one will just finish right here, meaning that's where we'll print from next if you do another thing. So yeah, so comments, single line comments, we've got it's just 2/2 forward slashes. So this is a comment, as you can see here. Multi-line comments are / asterisk ends with a asterisk back /. And you can then write sentences that can be broken in half and separated on a different line. Okay? Yeah, so that's very simple stuff. It's not nothing hard to grasp your head around. Okay, so variables in C# are containers for storing data values. In C#, there are different types of variables defined with different keywords. For example, you got integers, doubles, chars, and strings and booleans. So you can see here, chars can store 1, 2, 3, negative 1, 2, 3, for example. Floats can store 19.99 or the opposite of that. Chars are singular characters, so B, A, Z, whatever. Strings are like hello world, or I'm Isaac's dev corner, stuff like that. Bools are true or false statements. So syntax for declaring a variable would be the type, and then the variable name equals the value of you're putting in. So for example, it's integer, and then variable name would be integer cookie equals 3. So there's 3 cookies or something like that. I don't know. For example, where type is the int of string, and the variable name is the name of the variable, such as x or name. Equal sign is used to assign the variable. Used to assign, yeah, exactly. So, for example, we have a variable called John. So string name equals John, console.writeLine John. Substituting name into the console.writeLine, which is going to be printing out John in the console. And this is what the console looks like. I've cut it out a bit, but it's basically where your code will be executed in that visual way, and where you can interact with it and by typing values in when we do that later with user inputs. But create a variable called mynum of type int and assign it to the value 15. So integer mynum equals 15, mynum, which is 15. So this is very simple stuff. I'm assuming if you're looking at C#, you've obviously gone over Python and different basics and that kind of stuff. So yeah, you can also declare a variable without assigning it to the value and assign the value later. So for example, you've got mynum, which is of type int, and then you assign mynum to 15 on the next line later. And then you can print that out and it'll show up there. So change the value of mynum to 20. So you got int mynum equals 15. Mynum equals 20 is now updated, and then that will be what presents itself. So other data types that we've got here, I'm going to be going over them in a second more, but this is a brief example of what you got. But in terms of constants, so constant variables, if you don't know what they are, basically it enables you to keep a variable so you or someone else cannot overwrite the variable. And you got to add the constant keyword in front of the variable to do so. Sometimes you have a variable that you don't want to be changed. For example, pi, 3.14, whatever it is. You don't want that to be changed at all. So you maybe make it a constant or something like that. All right. So if you try and change it, you'll get an error. Something like this. It will look something like this. All right. So you got your constant 15, and then you're trying to change it and then print that. Obviously, it puts out an error because it's a constant, it can't change. Think about constant as in consistent. It's consistent throughout time. It will not change regardless. If you don't want others or yourself to have right values, you can add the constant keyword. Yes, we understand that. That's how it works. And you get the pi example there, and that's all cool. So the write line method is often used to display values to the console window. To combine both text and variable, use the character plus. So, for example, we have John and Doe. String full name equals John plus Doe. And you can see there, you've added those two strings together of the type string. So as long as they have the same types, it should be fully compatible at this current moment. But we can do typecasting later to change things. You've got multiple variables. So we got int x dash comma z comma y, and we can then assign them all equal to the same amount, which is going to be 50. And we can then do some math. So 50 plus 50 plus 50 is 150. So you can see the logic behind this, how it works, right? So you can also, yeah, as I said, you can just store variables like that, and then you can assign values to them later. You could even go x equals 50, do the semicolon, space, x equals 50, enter, x equals 50, blah, 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 right? You could y equals 50 and so on. You could break it up. You don't have to do it like that, but that's more efficient, right? So the next one is data types. As explained in the variables chapter, a variable in C# must be specified data type. So we've got int double char bool string, and we got that there. But here's a more comprehensive chart of what it looks like. So integer is a 4-byte size. I can store values from blah, 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 blah. You get it, a very big number. A long is even bigger, which can store much more, and it's 8 bytes. A float stores fractional numbers sufficient for storing 6 to 7 decimals. Double is 8 bytes, storing 15 decimal places. Digits, sorry. And a bool is a true or false, which is 1 bit. And a char is 2 bytes, stores single characters, letters, and single quotes. And string is 2 bytes per character, stores a sequence of characters surrounded by quotes, as we've gone over that before. So here's some examples of this. We have integer types. Yeah, so int my num equals 1,000. Is that 100,000? Yeah, 100,000. So console write line 100,000. That would be that. A long would be printing out this giant number. And yeah, floating point is going to be 5.75, which is of type float, decimal place to the 2. And we'll print out that there. Booleans would just be, okay, is C# fun? True. Is fish tasty? False. Console write line is C# fun. It would print out true, and then that prints out false. This one is a char. So char migrate equals B. Console write line migrate, which we're going to print out B. And yeah, string, we've already done that. So string greeting equals hello world, print out greeting in console write line. Yeah, fill out this little test here. So that's going to be integer. This is going to be double. This is going to be a char. This is going to be a bool. This is going to be a string. Next thing is typecasting. So what is typecasting? Typecasting is the process of converting the value of a data type, such as a int, float, or double, into another data type. This conversion is done either automatically or manually. The compiler performs the automatic conversion, and a programmer does the manual conversion. So there's two different types of conversions, manual and automatic. Brocode does a really good video on this one. So you can go check his out. It's he's probably better explaining things than me and much more efficient. So you can go check him out. He's got a good series in C# too. But yeah, so implicit, which is the automatic one, which is done by the computer, is a smaller size type to a larger size type. So this is, for example, going int to double. So int my int equals 9, double my double equals int. So then you're converting integer into double, and then I just did the .get type to print out what it does. So this output, they both output 9, but the types are different. So the type is double and type is int for this one. Does that make sense? So you've converted it via typecasting. And it's the category of casting is implicit casting, which is automatically done by the computer. Explicit casting is done a bit differently. It's done manually by placing the type of the in parenthesis in front of the value. So for example, we have double my double equals 9.75, which is a double, and we want to go down to an integer. So the way we do that is we create the int. So int my int equals int my double. So you're explicitly coming in here, changing its type into an int, and then assigning it into my int. And then from there you have the double and then the int displayed here. And then you can see I've added this bit here, which says 9.78, which is just showing you that that's the double. And when you convert it to an int, you can't have any space, any decimal places, so it just converts it to a flashy 9. So it just cuts it, doesn't round it, just cuts it. just cuts the decimal place off, and then it'll just keep the 9 there. So type conversion methods, we have using the system, right? I said there's different methods and all that stuff. There's methods to convert data types explicitly by using built-in methods such as convert to Boolean, convert to double, convert to string, convert to 32.int, convert to 64 long, blah, blah, blah. So, for example, here, you want to convert to string, my int to a string. So you want to convert this to 10 to a string. You can do that. You can convert it to a double. You can convert it to a my double to an int. You convert the Boolean to a string. So you can really do a lot of different things with typecasting, changing types. But the key is to understand implicit and explicit, and then you can work from that to then execute your ideas and the sort of changing of variables, data type that you want to do. So next up, guys, we're going to be covering use inputs, operators, math, strings, booleans, if else, switch, while loops, for loops, break, continue, and arrays. And then after that, we're going to be going into like classes, objects, all that good stuff, polymorphism, inheritance, encapsulation. And then the 4 pillars of object-oriented programming. This is the basics. I'm trying to make it so it's fast so you guys can easily understand. But yeah, look forward to the next one, guys. It's going to be very similar. And I'll catch you guys in that one. For now, have a blessed day and see you next